Hello, in this video I would like to do a demonstration of a typical workflow when processing a project in Correlator3D. I will use a standard UAV project, but for most of what you will see, it's also applicable for large format image and sensor or satellite imagery. First of all, I would like to say a few words about Correlator3D environment. So here you have the map view, where you're going to overlay your different layers, and on the left it's the project tree where you can open and close these layers. Take note that there's different things you can do in the project tree. For example, you can save your elevation model, or you can disable some images and flight lines from the processing. So be sure to have a look of all the function that you can use directly from the project tree. So I'm going to start a new project. I'm going to go in File, New Project, and I'm going to start a UAV project. So you can see the different type of sensor we are supporting. Today I'm going to do the demonstration with a UAV project. So there's 3 steps to create a project. The first one, you will add your images. So I'm going to go in a folder and look for my images. You could add a complete folder in one click, or you can just do select all of your images like this, and you will add them. Then the software prompts you to import the exterior orientation parameters, which are the geotag, the camera positions. So for most UAVs, if you have the camera position in the EXIF header, that will load automatically here, and you're going to see the coordinate of all your camera position, and then you can do add and continue. Now I just want to show you, you can also load the text file if you have this information from a text file. So I'm going to load the information here, and then you can define the different columns that you have. So it supports any type of text format. It's very easy to specify how your text file is formatted. So I'm going to change a few parameters here. I'm going to say I'm having omega, phi, and kappa. So I'm defining the different column: easting, northing, elevation, omega, phi, and kappa. By the way, you don't necessarily need to have omega, phi, and kappa. To start a project, you only need position in X, Y, and Z, and could be geographic coordinates or easting, northing coordinates. I'm going to do add of these images. Here I'm going to define the projection. So we support any type of projection. You can do a search with the PSG code, and if you have a state plane projection, you will find it in the command system here. In that case, I'm going to choose a UTM WGS84. It's in meter, and it's zone 18 north. Here you have a summary of the images you have imported, but also you can't add another camera. So there's 2 situations where you would like to do that. Maybe you have different cameras of different flights and you want to process them in the same project, or maybe you have multiple cameras on a rig, or maybe even you have the same camera but you did different flight on different days. So in that case, we would recommend maybe to import each of your flights in different cameras. So you simply add a new cameras, and then you will have the option to import the image from your other camera. I'm going to do next. So the step 2 is the camera parameters. So you have to check what type of sensor you're using. So if you're using large format camera, here you're going to use a digital model without distortion, and you will probably have a calibration report where you will fill the principal point and the calibrated focal length. For UAV project, you will select the digital polynomial camera, and we have a database and we with different cameras, so most of the time we should automatically fill the pixel size and the focal length, and it's the two information that are needed to at least create a project. Everything else you can just let this to 0. The last step is to simply define where you want to create your project. So I'm going to create this in temp. And that's it, your project is created. You have a background from the internet, you can close it. You will see your flight lines, your different flight lines. You can click on any images, you will have a preview here with the metadata on the left, bottom left. You can open the image. You see the image is already oriented in the flight direction, so you can double check if everything is properly aligned. If you open to image, you can see they're correct. So this is the initial project setup, and now you are ready to process. Now to start processing in Correlator3D, you have two different options that you can use. The first one would be to use the automated workflow. The automated workflow will go through the different steps and will generate the output automatically. So you can use this if you want to process your project all at once automatically. You can change the different parameters before processing, and you can also use different profile that will change a set of parameters. For example, I can here use a quick project overview, so it's going to generate very coarse outputs to have a quick overview of your project. You can also use the automated workflow if you want to generate a script. If you want to start scripting, this is going to generate a script from the set of parameters you have selected. And I suggest, if you want to use script, to have a look to the manual where all the syntax is explained, and how to run the script from command line. So everything in the interface can be scripted. But the automated workflow can be used in the interface if you just want to run the project automatically. If you want to interact with the project, you need to measure ground control points, you want to edit your elevation model, you want to edit your mosaic. You might prefer to go into each module interactively one by one. So if you go in modules menu, here you have all the different modules, and they are in the typical order of the workflow of a project. So you start with the RL triangulation, then you will generate your surface model. You can extract a DTM. We have tool to edit them. You can, after that, generate the ortho mosaic and do the mosaic editing. So the first step is to perform the RL triangulation. So when you click on the RL triangulation, you enter in the module. The software will ask you to measure the type points, do the type point extraction. So it will attach all of the image together. So if you run this, it might take a few minutes, so I will not do it right now. I will open a project where everything was done, and I will show you the different results. I'm going to go into my demo project here. And we're going to go back into the RL triangulation. I will show you the result of the type point extraction. So the RL triangulation has 3 steps. The first one is the type point extraction. Here you can see now there's all these links between the images. So it shows you that the software has attached all the image together with type points. You can even right click on the points and see what the software has measured. You don't need to go and review all of these points one by one. Fortunately, the software measures so much of them, it's able to remove the bad points automatically. So the type point extraction is a process that's entirely automatic. So the type point extraction is the first step. The second step is to import ground control points. This is an optional step. Maybe you don't have any ground control points, then you can run the RL triangulation without ground control. If you have ground control points, then you import them using this tool, and it's going to use a text file that you can import like this. There are just 2 points, and then you simply specify each of the column and you import them into the project. When you import a ground control point, they will be displayed in the project tree as here, as you can see. And you have the option to edit the points. So that point is already measured. As you see, the mark is green. So you see the point, it can be measured on all the image, so you can browse like this. If you want to change the point, the type point, here you go in this section and you can change it for a checkpoint if you want. The second point is not measured, so I will show you. If I click, you see now the mark is gray, so I just go into each point and I can refine the location, and as soon as I move one or two of the point, it will kind of adjust on the other image. So it's very quick to go into all images like that and just confirm the location of the point. It's very useful tools, the GCP measurements, very easy to do in Correlator3D. So once you have measured all the points, you save the measurement. Then the last step of the aerial triangulation is to perform the bundle adjustment. So that's where the software will do the final camera position adjustment, sensor calibration, and will attach all of your block and tie it to the ground if you have ground control points. Now, for most UAV project, probably you will run that with the default parameters here, so you just click process. If you're using a large format calibrated camera, maybe you just want to turn that to known because you don't want the software to do more calibration. But for UAV, you will let the software do a self-calibration of the camera. And then when you process, it's going to generate a step here of 80 in the project tree, as you can see. And you can have access to the aerial triangulation report. So in this report, you are going to find different statistics. Here I'm going to run it again just so we have some residual on the GCP. So I'm going to do another bundle adjustment, and I will include the GCP. You will see it's not very long to do. And then we will have the residual on our ground control point as well in the report. So when you run the bundle adjustment, the report should open automatically at the end, as you are going to see. And now you see we have some residual on our ground control point as well here. And here it's the residual on all the tie points. So this kind of tell you how good the block is attached together. So it's about the relative accuracy. And here is will tell you how accurate the block is compared to ground truth. So the absolute accuracy of your adjustment. And in the report you have different statistics and information on the image adjustment, camera calibration, and at the end you will have a report for each individual point. So usually for a project, you only have 2 GCP for the demonstration, but it would be kind of a minimum of at least 4 or 5 points, and then depending how large your project is, you might have more ground control points. But 4 to 5 points is a good place to start as a minimum for a project. So the bundle adjustment is done. You will have the color disk on the screen is a visual indication of how good your adjustment is. So it is the mean residual of all of your images, of all the tie points for each images. So you will see here on the left you have a color bar, 0.75, 1.5, and 2 pixels. So this is the mean residual per images in pixels. So here you see that everything is very good, all under 0.75 pixel. So very visually quickly you can have an idea of how good your adjustment is. And I suggest to, even if you run a project using the automated workflow or you do something automatically, always review the aerial triangulation report. Very, very important. That's where everything is happening. If you don't have a good bundle adjustment, a good aerial triangulation, you might have problem later in the processing, and that's where all the accuracy will be defined. So be sure to review your AT report and validate the residual of your ground control points. So this is for the aerial triangulation. Once it's done, we just exit the module by clicking again on the icon here. And now we're ready to go to the next step. The next step would be to do the DSM generation. But if you have an external DEM, an existing elevation model, you can also import it in the project and use that for the ortho rectification and the mosaic. So if you have an existing DEM, you don't necessarily need to do the DSM generation. You can import that in the project, and that way you save time in the processing. But here we can also generate our own DSM from the images. So when I go in the DSM generation module, the software will propose by default an optimal resolution, an optimal density for the elevation model, which will be about 5 times the resolution of your input images. So it's a good compromise between level of details and speed of processing. You can also do a maximal resolution, but obviously this will create a larger elevation model. It will be longer to process and might also as well have a little noise in the results. I suggest to start using the optimal resolution, or maybe something in between you can manually enter. Let's say, for example, here I'm going to use 3 centimeters. Vertical accuracy, most of the time I think you will want to use precise. Again, it's a compromise between speed and accuracy in the vertical accuracy. So if you're doing some accurate project, always let this option to precise. Also, if you want to generate a point cloud, you will need to check that option here. So by default it's unchecked because Correlator3D doesn't need a point cloud to do the ortho rectification. We are generating a raster DEM, and that's what we are using for the ortho. And so it's going to save time. If you don't need a point cloud, you just leave that unchecked. It's going to go faster to generate your DEM and then do your ortho. If you need a point cloud because you need to deliver a LAS point cloud, you just check that option and a point cloud will be generated along the DEM and it will be loaded here in the project tree. So if I click process, the software will generate the DSM. That will be a surface model. It will have all the buildings, cars, trees, and everything that you can see on the image will be in the surface model, as you can see here. If you have checked a point cloud, that will be generated as well along the surface model, and you will have your point cloud here like this. As you can see now, we have a point cloud that is included. Now the DSM, what you can do with the DSM is that you can filter out the building trees to have a DTM, and for this we have a tool, a DTM extraction, which is an automatic tool, very powerful. It's a automatic filter. It will look for difference of elevation and will try to remove the surface objects. I suggest that in some cases where you have already some bare earth topographic feature like this here, there's these stockpiles, a very steep feature, you can exclude those areas from the processing to avoid the software to filter or maybe remove even some of these topographic feature that you would like to keep in the terrain model. So you can use exclusion area. So if you have a shape file that will include this area, and then you run the tools for doing the DTM extraction, and you will have a terrain model where all buildings, trees, and cars has been removed, as you can see now. And from this you can generate contours. You can go in the processes, DEM contours extraction, and you could generate the contours from the terrain model. As you can see, it's very quick. It's going to generate a contour file here that you can save as a 3D shape files. So that is for the terrain DSM and DTM extraction. Regarding the point cloud, last thing I would like to say is when you generate the point cloud, that will be colorized by elevation like this. And once you will have your mosaic generated, I will show later how to generate the mosaic. The point cloud can be colorized with the mosaic, with the RGB value of the mosaic, using the tools here in processes, point cloud colorization. And when you do this, then you will have a point cloud that will kind of be colorized using the mosaic. And so it will look like this. Now you see we have the point cloud, the colorized point cloud. The point cloud can be exported in LAS, so that's the format in which we support a point cloud. Then it's also possible to edit your elevation model. So we have a DEM editing module that are very interesting tools to edit your elevation model. So I'm going to select the DSM again, and I will show you what you can do in the DEM editing module. So if I go in the DEM editing module, you will have different tools here on the right. One of the first tools is you can draw polygon. So sometimes I will simply use the DEM editing to draw some polygons. So I was talking about exclusion area. So you can use the DEM editing module to create different type of areas and polygons. So here I'm drawing a polygon and I can save it as a shape file and I can use it later in the project. But you can also use different functions for editing your DEM. So let's say here I have this object and I want to remove this object from the surface model. So I can draw a polygon around the object. And I'm going to show here in 3D as well. And there's different tools here. For example, you have delete and fill a selection. So this will delete and interpolate inside the polygon, so it will remove the object. So it's very easy to use. You just draw a polygon around different objects, and that way you can filter them out from your elevation model. So that would be a way maybe to manually remove things in the surface model, or if you want to do correction in the DTM, you can use that tool. You can also, for example, if you have water and you want to flatten out an area, here I can use the mosaic to help me in the DEM editing module, and I will draw a polygon of this little pond here. You see I can refine the points. And I can look in the surface model, the elevation around, you see we're about 374.4, and then I can just use cell elevation, 374.4, and this will flatten out the surface, as you can see in the elevation model. So you can import existing polygon if you already have some lakes digitized from another source and you want to flatten out these lakes in your elevation model. So you can import them, use the set elevation tool, and enter the elevation. Also, there's other tool like you can filter a selection. You can apply a mean or median filter. This will smoothen out some feature if you have some edgy or noise. You can also extract a DTM. So this will run the algorithm, the DTM extraction algorithm, on a polygon. So if I draw a polygon around this and I run the DTM extraction, well, the algorithm of filtering will be run only on that part. You can also paste a DEM from an external source. So let's say you have a small DEM, maybe a bridge you want to keep, so you can bring it back into your DTM and pasting it using that tool. Obviously, you can use different tools to finalize your DEM. So let's say I want to crop here. I want to crop my elevation model to a polygon. I can use the crop function here. Or if I want to delete a part of it, I can also use the delete DEM, and that way you can finalize your DEM. When you're done, don't forget to save. Here you go in the project tree, save as your DEM. You can give a new name, and it will load in the project tree. You will keep your original DEM untouched. So that's what you can do in the DEM editing module. There's a lot of tools, and that way you can really fine-tune your elevation model before you deliver to the customer. So this complete for the DEM, DSM, DTM, DEM editing modules. And now that we have our elevation model generated, we can do the ortho rectification. But before doing the orthos, be sure to select what elevation model you want to use. So here I'm going to select the DTM. There's two types of ortho you can do, and Correlator3D will give you the options to do both of them. You can do a true ortho, which is based on the DSM, so you only need to check that option, and be sure to have the DSM selected if you want to do a true ortho. Or you can select a DTM and you leave that unchecked, and it will do the ortho rectification based on the terrain only, and we'll only rectify the terrain. So depending what you need to do, we have both of these options. Then the rest of the settings are usually we will let that by default on the resolution. This is the optimal resolution based on the resolution of the your input images. And if you want, you can crop your orthos already during the generation. So if you want to remove the boundaries, the extent of your of orthos, you can just crop with a certain some percentage. And then you will run the orthos, and they will be generated all one by one. And they won't be color balanced yet. Will just be stacked on top of each other, as you can see. So if you want now to have a single color balance file, you will have to run the mosaic creation. This is the last step to get seamless color balance images. And then you just run this. For a large format project with camera already top down, you can turn off the nadir optimization. And for UAV project, this might give better result, especially if you do a true ortho. You can use this to optimize the nadir part of each of your photos during the mosaicing. So when you process, you will have your mosaic generated, and you will have your single color balance file like we have here that is generated. And maybe a last tool that I would like to show you is the ability to edit the seam lines of your mosaic. So you want to finalize how the software has assembled the different orthos into a mosaic. So you can edit these lines. So for example, maybe I would like to go around the buildings. I don't want the seam lines to go through that building, so I can use here, I can redraw the line like that, and I will see interactively the effect of my editing. I can also save that and reapply on the mosaic. So you don't need to run all the mosaic again. You simply had to apply your change or modifications on a mosaic where it was done. So it's very quick to go through the mosaic, and you can do the different modification like this. So if I maybe just want to edit this a little bit like this. So now everything is good. So you can refine your seam lines, save. It will show in blue the modification, and then you reapply. So rather than rerunning all the mosaic again, it's just updating where you have done the change. And so it's very fast to go through the mosaic and do quality check, and if you need to change the seam lines, you can do the modification with the mosaic editing tool. There we go. Other thing you can do in the mosaic editing module is that you can do a color adjustment. So it's possible to adjust the brightness of your images or the contrast. If you just use those brackets here, you want to have a more contrasted picture like this, and you can preview back and forth the modification. So when you're done, you process the adjustment on the mosaic. Be careful because this will apply permanently on your mosaic. You might want to do a backup first if you're not sure. The adjustment can also be done on the individual band. If there is some color problem, you can try to adjust them per band. If not, you will just work on the master, RGB master, and then you can do different color adjustment. So this is for the mosaic editing tool. Then when you leave the module, you will go back into Correlator3D environment, and you can reopen the mosaic. So this completes the overall overview of the workflow of Correlator3D. If you have any question, you can send us an email. We'll be happy to help you. So I hope this was helpful for you. Thank you for watching.